Hello everyone, and welcome back to our channel. Today, we have an incredibly important topic to discuss: diabetes and its connection to something called epigenetics. You may have heard of diabetes as a common ailment, but did you know that there's much more to it than meets the eye? In this video, we're going to explore how diabetes has become a widespread public health issue, and how epigenetics plays a crucial role in our understanding of it. Before we dive in, ready to transform your diet and embrace a healthier lifestyle? Begin your journey towards fat-burning success with a customized keto diet. Check out the link in the description. And now let's begin. Over the past few decades, diabetes, particularly type 2 diabetes, has emerged as a significant public health challenge. The reasons behind this epidemic are diverse, ranging from pre-existing medical conditions to unhealthy lifestyles and genetic predisposition. But what's even more intriguing is that animal studies have shown a strong link between epigenetics and diabetes risk. This connection opens up new possibilities for better prevention, diagnosis, and treatment of diabetes, even for those at higher risk. Now, let's take a moment to understand the gravity of the situation. Diabetes is incredibly common, especially in Western industrialized nations. For instance, in Germany, about 7.2% of adults live with this metabolic disorder. The consequences of diabetes are severe, ranging from acute complications like hypoglycemia to chronic conditions affecting the eyes, kidneys, and nerves. It's a challenge we can't ignore. Diabetes comes in two primary forms: type 1 and type 2. Type 1 diabetes, which affects about 5% of diabetes patients, is characterized by a genuine lack of insulin. This is due to an autoimmune process where the body's immune cells destroy the insulin-producing cells in the pancreas. It typically starts in childhood or adolescence, with sudden and unmistakable symptoms. Type 2 diabetes, on the other hand, affects over 90% of individuals with diabetes. It's associated with insulin resistance, which means the body's cells don't respond to insulin as they should. The symptoms here are subtler and often lead to delayed diagnosis. So, what causes diabetes? The origins of type 1 diabetes are still not entirely clear, but viral infections during early childhood are considered potential triggers. On the other hand, type 2 diabetes risk factors are better understood, including imbalanced diets, obesity, and smoking. But what's fascinating is that both types of diabetes are multifactorial, involving a mix of genetic and environmental factors. Now, this is where it gets really interesting. Genetic predisposition accounts for a significant portion of diabetes cases, about 30–50% for type 1 and 50–90% for type 2. But here's the catch: having a genetic predisposition doesn't guarantee that you'll get diabetes. And this leaves us with a big question. Why has diabetes become so much more prevalent in recent decades? This is where epigenetics comes into play. Epigenetics is all about how environmental influences can affect gene activity. It's not about changing your DNA but changing how your genes are expressed. One example of this is the impact of the post-World War II famine on subsequent generations. It led to epigenetic changes that influenced not only the immediate offspring but also future generations through both parents. We've seen evidence of epigenetic changes in animal studies too. For instance, nutrient deficiency in pregnant rats increased diabetes risk in their offspring, lasting for multiple generations. Similarly, an oversupply of food, like a high-fat, calorie-rich diet, can lead to changes linked to a higher risk of metabolic disorders in offspring. Remarkably, these effects aren't just from the mother's diet but can also result from the father's diet, highlighting the role both parents play in their offspring's epigenetic profile. So, what's the practical significance of all this? Well, understanding your epigenetic status can help assess your personal risk for diabetes and tailor prevention strategies. The better these strategies align with your epigenetic profile, the higher the chances of success. This personalized approach could also extend to treatment, where certain epigenetic profiles might respond better to specific treatments. It's an exciting path towards more effective diabetes management. In conclusion, while there's still much research to be done, one thing is clear: Much like genetic predisposition doesn't guarantee disease, your inherited epigenetic profile isn't set in stone. You have the power to modify it through your own behaviors, and sometimes even reverse it. In this regard, your lifestyle plays a pivotal role. So, whether you have a family history of diabetes or a specific epigenetic profile, you can take control of your health by adopting a balanced diet, managing stress, and embracing regular physical activity. The benefits of these changes extend not only to you but to future generations. That brings us to the end of this enlightening discussion on the fascinating connection between epigenetics and diabetes. I hope this video has shed some light on the complexity of this condition and the promising avenues for a healthier future. If you found this video informative, please give it a thumbs up, and don't forget to subscribe for more exciting insights into health and science. Thank you for joining us today, and remember, your health is in your hands. Stay curious, stay healthy, and we'll see you in the next video. Bye for now.